Hello, everyone, and welcome to this year's Spinnaker Summit's Delivering Golden AMIs with Spinnaker. My name is David Hurng, and I'm a Senior Site Reliability Engineer at Salesforce Einstein. And today, I'll be talking to you about how to develop and deliver golden AMIs with Spinnaker. So let's get started. First off, what exactly are golden AMIs? Well, a golden AMI is ultimately an Amazon machine image that is pre-configured with the OS of your choice, as well as embedded with the software that's required to run your applications. These AMIs are standardized through configuration, consistent security patching, and hardening. They need to be continuously assessed and scanned for vulnerabilities prior to distribution and deployment to your business units. They are also constantly being replaced by newer AMIs as they quickly become outdated as new vulnerabilities are discovered. So why do we care? Why do we go through all this work to reproduce an AMI that I can find on the market and use? Well, many of you here are probably facing the same types of issues with that approach, in that there's an inconsistency in the images that are being used throughout your organization, as everyone is free to use whatever AMIs they see fit. And don't forget that these machines are likely littered with vulnerabilities that can pose major risks. So now that you know a little bit about golden AMIs and how they prove useful to you and your team, let's talk about how we can deliver them with pipelines. Think of a golden AMI pipeline as a perfect way to ensure standardized processes while maintaining checks and balances. First off, it saves time. We can expect an automated process as opposed to a manual step-by-step playbook, which tends to be prone to mistakes. Second, it ensures consistency. Rather than have an ad hoc deployments with random floating images, you can restrict your team to only deploy with the improved, secure list of golden AMIs. Third, AMIs are hardened, meaning that potential threats against instances are neutralized as unwanted and unnecessary services, access, and programs are removed. This can also make AMIs much more lightweight if needed. And finally, aside from preventing attacks from hardening, there are continuous assessments of vulnerabilities, so you can expect your AMIs to always be measured against the latest security standards. Each AMI will also be equipped with agents that provide logging, security, and performance monitoring. And as an added bonus, golden AMIs also make auditing time much smoother. So what does a golden AMI pipeline look like? Well, AWS has many resources and case studies that demonstrate a working pipeline that integrates with AWS Inspector, as well as third-party inspection tools such as Qualys and Tenable. The general idea and the flow is the same between all these pipelines, however. We can expect the creation of a golden AMI through a general process as shown. Hardening the selected image. Again, this can involve removing programs and services, as well as blocking any ports. Validating the image with some sort of inspection process. Approving or rejecting the image. If rejected, decommission the AMI and start another, or simply patch it up. If approved, register the AMI as active and up-to-date AMI. The approved AMI will then be ready for distribution for consumption, and then decommissioned once obsolete or reaches end of life, which is generally subjective to the team's standards. It is also best practice to allow these established golden AMIs to remain as immutable objects. So when there is a need to make a change to the AMI, it's as easy as updating the requirements and rerunning the same pipeline. Since this is a Spinnaker Summit after all, I won't dive too deep into AWS solution architecture. There are also plenty of resources that cover this in depth. But as a comparison to what we can accomplish with Spinnaker, let us look at how the deployment uses some of AWS Managed Services that we can adopt into our own Spinnaker version of the pipeline. The pipeline can be started with multiple triggers, manually, periodically, or right after a CI/CD pipeline. Once the source AMI is selected, an instance is created. Packages and libraries are updated, installed with any custom code for hardening, also installed with any required agents. Once the instance is stopped, an image is created. This is the golden AMI. As the next step, this golden AMI will be tagged accordingly with production information. The image is then used to create another instance with the same requisites. However, it will also an AWS Inspector agent to be installed. It also needs an AWS Inspector agent to be installed. The agent will be collected, installed package information, and any software configuration in order to fully assess their security. This instance is what will undergo the assessments. The AWS Inspector templates can be configured to run at a set cadence and pick up any new instances. Once Inspector finishes the assessment, it will publish an SNS notification for approval. This is the general flow of most golden AMI pipelines. I want to now introduce to you the Spinnaker solution. I took the key flow of what we saw earlier and integrated it alongside with the tools provided by Spinnaker. Let's go through the architecture. First off, we can also trigger the golden AMI Spinnaker pipeline with manual trigger, periodic trigger, or a CI/CD trigger. I won't go into the authentication or authorization step, as it is out of the scope of this panel. But I want to mention how Spinnaker will run the AWS service as a functional ID and not as a specific user. In other words, there will be one single AWS IAM identity due to the nature of this particular pipeline. To continue, the image will be baked, and depending on the template, it could be shared with the existing target environments. The hardened image will be tagged as a golden AMI candidate, so we know it is not ready to be used in production machines. Single instance will be deployed from this AMI, which will also have an AWS Inspector agent installed on top of everything else that is needed. We will then invoke a fire and forget webhook against the AWS Lambda that triggers AWS Inspector assessment to run. After the AWS Inspector completes the assessment, we can approve the AMI through a manual input stage in Spinnaker. From there, if the AMI is approved, it can be tagged with golden AMI approved tag and released for use. Else, the AMI will be cleaned up and destroyed. Here is a visual comparison of the AWS solution architecture with the Spinnaker architecture. The major intersecting points will be the shared AWS services, but the flow of the baking, tagging, and approving can be done all in band with Spinnaker. Here are some of the very fundamental prerequisites to get us started. Of course, we're going to need a Spinnaker installation. Start with configuring AWS as a provider and cloud driver. This will be the deployment environment where the instances will be created. When configuring, adding the AWS environment where Spinnaker is installed will actually make things easier, as there will be fewer networking hurdles to go through. Have AWS Bakery configuration set up. This will allow for the use of bakery defaults. The template files are stored within Spinnaker's microservice Roscoe, which runs simply Packer. So ideally, to make everything easier and automated, I'd recommend looking into GitHub Sync as a sidecar. This ultimately allows any merges on a target branch of a repository to be synced with Roscoe for baking. The AWS services will be out of band with the setup and the spin-up process, but all part of the automations go. We'll need a AWS API gateway for the webhooks coming from Spinnaker, protected with API keys, as well as a secure networking layer. I would recommend these AWS services to be deployed within the same environment as the AWS provider configured above for the same reasons. We will need an AWS Lambda to process the webhook and make logical calls to the AWS Inspector, a function to invoke the assessment, and another to confirm the completion and gather the report within the Lambda. Finally, AWS Inspector itself needs to be set up to have the job that targets images based on the tags golden AMI candidate. As mentioned earlier, we can optionally include a GitHub Sync sidecar. Also optionally, a custom job stage where you can run scripts to publish the golden AMI into a repo or any final touches. You can learn more about this in the next Spinnaker Summit workshop, Spinnaker Custom Job Stage. And of course, Spinnaker also has notification options similar to SNS solution that you can set up. Here's a snippet of a simple golden AMI Spinnaker pipeline. There is nothing else that needs to be done outside of running this pipeline. So emphasis on the automation and how everything is managed and controlled through Spinnaker. Let's dive in. The bake stage is the first step in the pipeline we see. The AWS Bakery will be configured within Spinnaker. You can establish defaults that abstract any complexity and makes configuring the pipeline much easier. We can take a look at what this looks like in the next section. Spinnaker's microservice Roscoe runs Packer against a specified directory. Again, this is where GitHub Sync Sidecar can come in handy. Whenever there's a merge on the master branch within a repo that contains the Packer templates, as well as the values and other scripts, it will automatically update the path within the Roscoe container. This removes the need of redeploying Roscoe containers, thus preventing any downtime. The template can also include a few other requisites, such as naming or other environments that to share. This is okay, as we will not allow users to use any AMIs that are not tagged for approval, regardless of the environment. Once the AMI image is baked, you can view it in your AMIs tabs in Views in AWS console. As we can see, the examples and features that AWS or that Spinnaker offers for AMI baking. The AMI defaults can be seen as selectable under base OS. All other file references are within the custom Roscoe directory that is linked with the GitHub Sync sidecar. The tag stage is pretty straightforward. Simply tags the newly created AMI with golden AMI candidate. Again, since this is an AMI that can be shared amongst other environments already, your team should be aware that candidate does not mean approved. Also, keep track of the tag being used here. That is what AWS Inspector template will need in order to do the matching and the searching. Next, the deployment stage will deploy a single instance of a golden AMI candidate. Much of the defaults are lightweight enough to proceed, but adding configurations such as a firewall will help, as it will be included in the vulnerability scanning. That being said, this is a good opportunity to scan for network vulnerabilities. Another key feature here is to include an encrypted user data. That installs any agents you need, but more importantly, the AWS Inspector agent, and it is required for scanning. Thanks to Spinnaker's Webhook Stage, we can invoke the AWS Inspector and keep the process automated without ever leaving the pipeline. We can also trigger Inspector on queue as opposed to having to wait for a scheduled cadence to scan instances, thus possibly missing any new instances, especially if the pipeline were to restart. The webhook stage will involve a post method to the webhook URL alongside any payload and any API key within the headers. Lambda will have a logical code to process the webhook requests accordingly. I have not published the code due to proprietary reasons, but it could be as simple as making another API call to AWS Inspector. AWS Inspector can be configured with the rules packages, such as common vulnerabilities and exposures, or those you choose to define for the assessment. It will also be coupled with assessment targets that use the tags AWS AMI candidate. Now that AWS Inspector is running the assessment, ideally now as recommended, we wait. We can include a wait stage within Spinnaker to wait until the results are complete. After that, we will run another webhook, but this time we can simply use a get method to get on the status of the assessment. This webhook will be similarly configured with the same network rules and the API key. It will also go through the same flow of API gateway to AWS Lambda to AWS Inspector for the reports. It is important for the Lambda logic to include searching for specific assessments. In other words, if there are multiple pipelines running or even an existing assessment that's not complete, make sure to take that into consideration, add that into the logic. Here is an example of the assessment report. This is a very lightweight AMI that I'm being used here to better show the in-depth vulnerability assessments. The rules packages used in this case are common vulnerabilities and exposures, network reachability, CIS OS security configuration benchmarks, and security best practices. This is the only manual step of the golden AMI pipeline, which can be done with the manual judgment stage. But we can simply set up notification rules defined within Spinnaker. The approval stage implies due diligence on the engineer to actually review the reports and findings discovered by AWS Inspector. The AMI is approved, we will tag the AMI as the golden AMI approved and can use custom stages to run a script to simply publish this AMI ID into a list of approved. If the AMI is denied, we will tag the AMI as denied. And to make sure that it does not accidentally get used, we can also include a cleanup stage to delete any instances and the AMI itself. One way to improve on the automation stage, on this particular automation stage, in the future, is that the assessment reports can be consumed as a data interchange format, such as JSON, instead of PDF or HTML. This way, there can be an automated response based on number of findings, for example. As a result, with this Spinnaker solution, you can now walk away from this panel having developed a golden AMI pipeline that's automated and reusable, having golden AMIs that are secure and hardened and ready for your business units to deploy with, and being able to meet compliance and satisfy auditing needs from the use of up-to-date scanning standards. Here's some of the following sources and case studies that AWS publish if you'd like to have further in-depth reading. Thank you so much for watching. Please feel free to reach out if you have any questions.